So we're going to do a net ionic reaction for the reaction that you saw here. Like, no, that's not it. Now, this reaction here where you see the lead iodide forming, that's what we're going to do right now. So, the way it works, your initial thing is going to be a PB NO3 with a 2 there plus Ki, and that's what you'd be given in the problem. That'd be your starting point right there. Now, the next phase of figuring this problem out is there's 6 steps you have to do. There are 6 steps. None of them individually are really that bad. It's simply when you start putting, all 6 of them together, it gets to be a bit of it's just a lot to do in one simple explanation. So, we good? Now, step 1. Step 1, I'm going to write it up here actually. Predict the products. So step 1, predict the products. Now, the way you actually predict these products, same thing we just did, on those couple examples that we attempted. All you do, you identify charges. PB is +2, nitrate is -1. K is +1, I is -1. Do you agree with me on those? Good. Now, the positive, I always do positive. You can do negative if you want to be different. The positive will trade places. They are going to literally you're going to take the K and you're going to put it over there. You're going to take the PB, you're going to put it over there. Okay? So, when you do this, you will end up with K +1. NO3 is -1. So you crisscross them, you end up with K, NO3. Remember, it goes away until you balance it then. You rewrite it. Now, the next thing will be PB and I. PB is +2, I is -1. Crisscross, so PBI2. Yeah. So, step 2. First, any questions on step 1? All right. Step 2, balance. Now, I'm going to rewrite it here just so you can have like a nice clean one to see, because it's always better that way. So, you get this. Now, in terms of balancing, you've got NO3 with a 2 there. You've only got one NO3 here. That's not good. You should fix that. So, the way you do that, you put a 2 in front of the entire formula. You cannot put it in the middle. You must put it out in front. What? Okay. Next step. Next part of balancing. You've got 2 I's, you got 1 I. Put a 2. Now it's balanced. Questions on that stuff? Alright. Step 3. Step 3 is the beginning of the new stuff, so now it's determine the solubility for each thing. So, this is where you use your solubility chart, your solubility rules. And it's up to you now to say, what's the deal for each formula. So, you look up PbNO3. The very first rule, nitrate salts are soluble. Nitrate, soluble. So you write aqueous. Next step, Ki, or next formula, potassium iodide. Salts containing alkali metals. Is that alkali metal? K is. So, those are soluble, so you write AQ again. Next thing, you have potassium nitrate. Nitrates are soluble. So, aqueous. And then the final thing, lead iodide. You look at the third rule here. Iodide is soluble except when bonded to lead, silver, or mercury. So it's bonded there, so it's a solid. No, not necessarily. Like I said, as long as you take it nice and slow and simple and you pay attention to this, you will do good. Yeah.
If it was something soluble, bonded with something insoluble.
See, the point is, though, it wouldn't. The rules address that. That's why, like, normally things bonded to iodide are soluble, except if it's something like lead, then it's solid then. That's what the rules do for you. They tell you that. Shiny what? Okay. Now, so that's step 3. Step 4. This is the long, annoying step. Pay attention. Just ask if it's hard. It'll be hard if you don't pay attention. So step 4. Write the total ionic equation. This is the part where you're gonna. This takes a little bit. What I'm gonna do is rewrite the initial equation down here, just so you can have it right in front of you when you see the example. Yeah, I'm just copying this down here. That's all. Yep. All right. So, write the total ionic equation from this. Now, the way it works, if something is aqueous, it will dissolve in solution. That's the idea. If something is aqueous, it will dissolve in solution. That means it will split apart, and you will end up having your, you'll have your ions, free ions, floating in solution here, like we've been talking about. Now, this is aqueous, so here's what you do. You literally are going to separate the formulas and write them ionically. It's going to take a bit. So you'll do Pb. It's a +2 ion. We established that right at the beginning. It's +2. It is aqueous. We only have one of them, right? Plus. How many nitrates do I have? 2. So here's the deal. Since it's no longer in a formula, all right, since nitrate is no longer in a formula, what this is basically saying now, you'll have 1 Pb floating around. You'll have 2 nitrates floating around in your solution, okay, when you put it in there. So you don't put a little subscript there. Instead, you simply write, you have 2 NO3s for this equation. So you just take it and you just put the subscript out in front. It's a -1 charge. It's aqueous. Yeah, you can just write negative without the -1. You keep going. You see how this takes a while now. 2 Ks +1 aqueous plus 2 Is -1 aqueous. Arrow. You've got 2 Ks again +1 aqueous plus 2 NO3s again, -1 aqueous. But then you stop. Because now PbI2 is a solid. So when you write that, you simply write PbI2 solid. You don't separate it then. You keep it together.
Wait.
Yeah.
The solid, it stays together, but...
The solid always stays together.
So you see how it's PbNO3AQ, since that one AQ means that both singular, like both separate, each one's AQ?
The AQ applies to the entire formula, yes.
You did the same here, obviously it was just broken apart.
So why did we do this? Because now we're going to cross a lot of this off. The point of this is to figure out what you get rid of. Because if you think about it, like I said, in the reaction that you see where you have the, the reaction going on there, only 2 elements are causing that yellow compound to exist. And the goal is that we're going to cross everything else off that doesn't do anything. So step 5 will be cancel spectator ions out. Spectator ions being the same on both sides. Yeah. So, what do we have that is exactly the same on both sides of the arrow? So, you got 2NO3, you got 2NO3. Exactly the same. Cross it out. You have PB. Is it exactly the same on the other side? No, it went from being an aqueous ion to a solid thing, not dissolved in water. Don't cancel that out. 2Ks, plus one exactly, ions, cross them out. 2 Is, you have 2 Is, but it's not in its ionic form. Can't cross them out. So, you've now basically finished. You have now established what will react. So the final step is write the net ionic equation. The word net implying that you're going to write only what actually happens. So PB plus 2 aqueous plus 2I negative 1 aqueous will produce PbI2 solid.
All this for that.
What? Oh, I was just showing you like where it divides. I was just saying this is like the dividing line for crossing out.
It's just a lot of work.
Yep.
Thank God I didn't miss.
What? Yeah, it's a good day to come, huh? What, Hassan?
Can you please re-explain number 5? Like, what do you cancel out? What do you?
You cancel out the things that are the same on both sides of the arrow. So, like, if it's exactly the same, that's all you do. You just cancel them out. Like, so 2NO3s cancel. 2Ks cancel.
What about the I?
The I is not the same. See how it's different there? Solid aqueous, you can't cancel it out.